Alright guys, here's a video to recap what we did today in class. So Unit 4.5, Lesson 2, we're going to learn how to divide complex numbers and simplify expressions involving complex numbers. The first thing I need to take you through in these notes is something called a math conjugate. A math conjugate, or just a conjugate in general, is formed by changing the sign between two terms in a binomial. So fill that into your note sheet if you haven't already. For instance, the conjugate of x plus y is x minus y. Now, why is that important? Well, let's look at an example. Your conjugate, so if I have, say, 5 plus 4x, and then my conjugate is 5 minus 4x, the conjugate really takes away your middle term. 5 times 5 is 25. 5 times negative 4x is negative 20x. 4x times 5 is 20x, and 4x minus 4x, or 4x times negative 4x is negative 16x squared. Notice your middle two terms of negative 20x and 20x, they're going to cancel each other out. That leaves you with 25 minus 16x squared. That's also known as a difference of squares from our factoring unit. So every difference of squares, the factors end up being conjugates of each other. Neat. What does that have to do with what we're talking about? We're talking about complex numbers, so we need to talk about complex conjugates. A complex conjugate, or what is the complex conjugate? A plus bi. Well, it's very similar to a regular conjugate. It's going to be a minus bi. Okay? So some examples on your note sheet. You need to find the complex conjugate. The complex conjugate of negative 4 plus 5i is negative 4 minus 5i. Go ahead, pause the video, see if you can figure out the next three. Hopefully you got the same exact answers as I did. So why? Why do we need this? We need the complex conjugate for division, because when we are doing division problems, we need to rationalize the denominator. If you remember in our radicals unit, we could never have a square root in the denominator. So some examples of that are 6 over the square root of 3. How do we get rid of a radical in the denominator? We multiply by the square root of 3 to the square root of 3. That becomes 6 square root of 3 over, well, the square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is 3. Then we can simplify 6 over 3 to become just 2 square root of 3. Now, in the second example, this is something new involving our conjugate. All right, so we have 3 over 5 plus the square root of 2. The conjugate of 5 plus the square root of 2 is 5 minus the square root of 2. And by multiplying our numerator and denominator by that, we're going to get rid of the radical in the denominator, or we're going to rationalize our denominator, which we have to do to get a rational answer. So here we go. Our numerator, 3 times 5 is 15. 3 times negative root 2 is negative 3 root 2. Easy. In our denominator, we have a binomial times a binomial. But if you remember from earlier when we talked about the conjugate, we said the conjugate's great because it causes our middle terms to cancel. So let's go ahead and take a look here. We've got 5 times 5, which is 25. But then we have 5 times negative root 2 and positive root 2 times 5. Those are going to cancel each other out. So now you're going to write them. Square root of 2 times negative square root of 2 is negative square root of 4, but the square root of 4 is 2. Now what we have to do is clean this up to get 15 minus 3 square root of 2 over 23. Now, let's talk about why we're doing this. With complex numbers, all right, the product of two complex conjugates gets you a real number. It gets rid of I. Okay? Why do we need to get rid of I? Well, if it's in the denominator, I is the same as the square root of negative 1. But we can't have radicals in the denominator. So we can't have I in the denominator, so we must rationalize. Now, before we get to that point, let's look at it in general. So in general, if we have A plus BI, and we multiply by the conjugate, which is A minus BI, we should get a real number according to what I just stated up here. A times A is A squared. A times negative BI is negative ABI. Positive BI times A is positive ABI, and BI times negative BI is negative B squared I squared. Now in our last lesson, we learned that I squared is the same thing as negative 1. So really on the end here, I have negative 1 times negative B squared, which is going to become a positive B squared. My middle two terms, negative ABI plus ABI, those cancel. And I'm left with A squared plus B squared. And if those are good numbers, that would give us a real number. There's no I left. All right, go ahead and pause the video, try the second example, or really the first example, on your own, and see if you can see how multiplying by the conjugate of negative 4 minus 5i gets rid of that middle term. If you notice, I just did the first step of multiplying through. I have 20i minus 20i, those go away. Remember, I squared is the same as negative 1. So now we have 16, and then negative 25 times negative 1 gets me positive 25. And oh hey, those are like terms. They're both real numbers. Add them together, you get 41. So multiplying by our conjugate allows us to get rid of the i's, which is what we want to do when we have a problem like this. We can't leave this I right here in the denominator. So we must rationalize the denominator. We got to get rid of the I because I is the square root of negative 1, and we can't have a square root in the denominator. So I'm going to show you one example. Probably going to stop the video and make a separate video for the remaining problems in practice. But to rationalize this, we're going to multiply by the conjugate of the denominator. So the denominator is 5 minus I. We're going to multiply by 5 plus I over 5 plus I. All right? The reason we're multiplying by 5 plus I over 5 plus I, we're really multiplying by 1. So we're not changing the value of 8 plus 3i over 5 minus I by multiplying by 1. So let's multiply that. So let's do our numerator first. 8 times 5 is 40. 8 times I is 8i. 3i times 5 is 15i, and 3i times I is 3i squared. Let's do the denominator, and then we'll worry about simplifying here. So, because we're multiplying by the conjugate, we should know that our middle terms are going to cancel. So we're going to be left with no i's. Well, let's just work it out so we can see it. 5 times 5 is 25. 5 times I is 5i. Negative I times 5 is negative 5i. And negative I times I is negative I squared. Let's go to our numerator real quick. Notice you have an I squared. Whenever you have an I with an exponent greater than 1, you need to simplify it. I squared by now, we should know, is negative 1. So 3 times negative 1 right here is going to get us minus 3 at the end. This 8i and this 15i are like terms. They're going to become 23i. And this 40 is just plain old 40. Okay? So in our numerator, I have more like terms. I have 40 minus 3 to get a total of 37. And then I still have a positive 23i. In my denominator, all right, I notice that I have an I squared, which I know is negative 1, but I have a negative 1 times a negative 1, which becomes a plus 1. 5i minus 5i, those cancel. And I have 25 plus 1, but 25 plus 1 is 26. And this is fully simplified because we've rationalized the denominator. I'm going to stop the video, make another one for the remaining examples and how to simplify with radicals. So stay tuned for part 2.